Welcome back. For this calculus problem, we are going to be solving for dy dx for the following two equations. X is equal to 1 minus t squared and y is equal to the inverse sine of t. So the easiest way to approach this problem is to rewrite dy dx in this form, dy dt over dx dt. And these are equal because we could just 1 over dt over 1 over dt would just cross off and you would just be left with your original dy dx. So with that in mind, we just need to take the derivative of both these equations with respect to t. So we have dx dt, and that's equal to 1/2. We're bringing the power out in front because this is raised to the 1/2 power. 1 minus t squared, and then we bring the power down by 2, reduce the power by 1, I'm sorry, and that becomes a negative 1/2. And then we have to apply the chain rule, and doing so we get a negative 2t. And then from this you can see that these 2's will cross off. And then when we rewrite it and clean it up a little bit, we get a negative t over the square root of 1 minus t squared. And we're writing it this way so we can get rid of the negative exponent. So we have our dx dt. And so now going to this side, we want to do the same thing, take the derivative with respect to t. But before doing so, it's easier to actually rewrite the equation by taking the sine of both sides. So we'll take the sine of y, and we're doing that because the sine of the inverse sine of t ends up just being t. So then this just ends up being t. And then now we can take the derivative with respect to t. So we do that to both sides, and I'm actually going to do this side first. So we'll say d dt, and then that's going to be equal to 1. And for this side, we can't do d dt directly because this is sine of y. So why don't we just do d dy? But this side is still not equal to d dt, so we'd write dy dt, and that's ultimately the chain rule. So now we have the dy dt, and that's really what we were trying to solve for in the first place. So we have dy dt times d dy of sine of y, and that just ends up being cosine of y. So now we can solve for dy dt, and that's equal to 1 over, actually let me write a straight line here. That's going to be 1 over the cosine of y. It's cosine of y. But we want this side of the equation in terms of t, not y. So it's really cosine of the inverse sine of t. And we get that from our original equation that was given here. So this would have worked out a lot nicer if this was the sine of the inverse sine of t. So what we're going to do next is we're going to use some Pythagorean or some trigonometric identities, specifically the Pythagorean identity. So we'll say the cosine squared y plus sine squared y is equal to 1. That should be familiar to everyone by now. And then we have cosine of y is equal to the square root of 1 minus sine of y. And I'm going to write it this way. I'm going to write it this way so you can see that when I plug in y here, I'm going to get sine of the inverse sine of y, which is just t. So this will be equal to 1 over the square root of 1 minus the sine of y. And again, y is just sine, inverse sine of t. And then this whole thing is quantity squared. So we can, over here, because I'm running out of real estate, we have 1 over the square root of 1 minus t squared. So this is dy dt. So finally we can put it all together, and we can take this expression and say dy dx is equal to 1 over, oops, let me clean that up, 1 over the square root of 1 minus t squared over negative t over the square root of 1 minus t squared. As you can see, the numerator and the denominator, they have the same denominator, so we can cross these off, and then really we're just left with negative 1 over t.